All right, rocking and rolling. Categorizing the polynomials. Like I said previously, you worked on the linear expressions of ax plus b, which is your linear form. And now we're working on the ax squared plus bx plus c, which is our quadratic form. Don't forget that these are called polynomials, okay? Excuse me. A polynomial is a mathematical expression involving the sum of powers and one or more variables multiplied by coefficients. A polynomial is one variable in the sums of terms of the form ax to the power of k, where a is any real number and k is a non-negative integer. In general, a polynomial is of the form a sub 1x to the power of k, a sub 2x to the power of k minus 1 plus a sub n with x to the power of 0. Within a polynomial, each product is a term of the number being multiplied by a power is a coefficient. So what did I just read? A bunch of mumbo jumbo. So this is extremely complicated that I know a lot of us are like, oh my God, Mr. Hermes, that's just way too much for me to know. Don't even stress about. Let's look at the work example. Right here we have a polynomial m to the power of 3 plus 8m squared minus 10m plus 5. It has 4 terms. How do I know it has 4 terms? Because I got them right here. 1, 2, 3, 4. 4 pieces of information that makes it 4 terms. Each term is written in the form ax to the power of k. The first term is m to the power of 3. The power is m to 3 and its coefficient is 1. Don't forget, it's saying there's an imaginary 1 right there. In this term, the variable is m and the exponent is 3. We're just breaking it down now, okay? Looking at this, here we go. So, since our first term is m to the 3, our second term is 8m squared. Our third term is negative 10m, and our fourth term is 5. After that, like we said, there's an imaginary 1, which is where that 1 comes from. Our coefficient here is 8. Our coefficient here is negative 10. And our coefficient for our last one is 5. There is no variable. There is no letter here, so it's going to be kind of interesting. Variable. Right here it is m. So we're going to say this is also m. This is also m. And right here, there's no variable for this constant at the end. Our power, this is m to the 3, m to the 2. Right here we could say m, but we can also say 1. Now put a star right here because this is going to be pretty interesting. This is m to the 0. Now eventually we'll get to understand that m to the 0 is just 1. Okay, so if m to the 0 is just 1 and we take that 5 and we multiply it, 1 times 5 just gives me 5, which comes straight back to this part right here. So anything to the power 0 is always 1. Okay, next exponent, 3, 2, 1, and 0. Terrific. Wonderful. Definitely consider this part and this part specifically, because I know a lot of us are going to be curious as what the heck, anything to the power of 0 is 1. And yeah, I swear, if I bring my calculator out, show you a quick example. If I put a huge number and I go to the power of 0, look what I get. Huge number to the 0 is 1. Very, very crazy. Okay, next page. Identify the terms and coefficients of each polynomial, sorry. I teach geometry sometimes, that's my fault. Anyways, okay, so our terms are given. We got negative 2x squared and we got 100x. There are 2 terms in this polynomial. Next, our coefficients are the numbers that are in front of our variables. We got negative 2 and 100. Okay. Next, there are 1, 2, and 3. There are 3 terms. Our coefficients are 4, -2, and -5. Right here we also have 3 terms. Our numbers are 1, -1, and 3. Why do I say -1? That minus sign makes that number negative. Don't forget that. In the next paragraph, if you read this on your own, like I said, here are the key things. 1 terms a mono, 2 terms is a binomial, 3 terms is a trinomial. Moving down a little bit. Okay. After that, the degree is obviously the exponent on the polynomial. If we read this little part right here, 4x plus 3, the greatest exponent is 1. So the highest degree of this is the power 1. Where do we get that from? 4x, another imaginary 1, plus 3. The highest degree in this function is 1. Don't forget, this is technically 3x to the 0. It's not given there because x says 0 is just 1, so anything times 1 is its exact same self, okay? Interesting. A lot of good conversation I hope that you're having in your classroom. Number 3. Khalil says that 3x to the power of -2 plus 4x minus 1 is a trinomial with a degree of 1 because 1 is the greatest exponent. Jasmine disagrees and says that this is not a polynomial at all because the power on the first term is not a whole number. Who is correct? Very, very interesting. Well, if you remember, Jasmine will be the correct one. And I'll show you real quick why. Come here to the first page. We got to remember non-negative integer. Okay? Got to make sure it's positive all the way around. Of course, there are rules. We got our negative exponent rule. We have our fraction rule, all that stuff. But if we're talking specifically about polynomials, this is not one to be reckoned with, okay? So we can say non-negatives are not oops, oh my gosh. Train crash. Sorry. Are not polynomials. If we look real quick, which one of these 3 is a polynomial? The only one that we can talk about that is a polynomial is right here. No negatives are welcome to the party. Right here is a rational, which is x to the half. That's not welcome to the party, so don't worry about that. This is the only guy that's invited to the party. All our exponents are positive. Looks like we can make some mess right here. Looks good to go. Last page of 1.1. I know it's a little lengthy. We're about to hit 10 minutes, so cut after this, I promise. Oh, this is easy. This is on your own. Number 5 is stating, take these cards. We already talked about that you would be cutting these out. You would say, oh, that's a mono, that's a bi, tri, also a mono, and you go through the motions and you put them in order right here. There are 12 squares, but right here there are 15, so just be careful. There might be more on each one of the ones, okay? Definitely do that on your own. Your teacher, whoever there is in the room, will check, and good luck.